Hey guys, this is Coach Lowe. We're talking tools of the trade and problem solving. This is contextual geometry. Make sure that you're on the correct recording before you start this. All right, so let's talk about section 1.5, tools of the trade. Put these in your definition section. If we talk about using a straight edge, it's any object that we can use to draw a straight line. It is not a measuring tool. It could be the side of your textbook. It could be an unmarked ruler. It could be a ruler as long as you're not measuring. A compass is any object that can be used to draw circles. The kind that we have in class and the kind that you're probably used to, they have a sharp point that you put at the center of the circle or where you want to be your anchor point, and then the other side has a pencil that you can move around. You can draw circles, and we'll do arcs and all kinds of fun stuff. We will talk about this in class and do some activities in class. So let's go on to 1.6. 1.6 is problem solving, and there are a couple of definitions that you'll need to put in your definition section. The first one is perimeter. When we talk about perimeter, we're talking about the distance around a figure. So if we are talking about perimeter of a rectangle, we are talking about how far it is all the way around the rectangle. So walking the perimeter is where that comes from, walking around the outside of the rectangle. When we talk about area, by the way, when you find perimeter, you add up all of those sides. When we talk about area, we are talking about how much it takes to cover a surface. So how much it would take to cover or to color in that rectangle. For a rectangle, we use the length multiplied by the width to find that area. All right, so let's go ahead and look at this rectangle. We are going to find the perimeter of this rectangle. All right, so let's start with that. Perimeter of the rectangle means just run right around that thing. Perimeter means add all the sides up. And for a rectangle, we know that the opposite sides of a rectangle are equal in measure. So I have two sides that are 7 feet and two sides that are 11 feet. So you have some options here. If you would like to take a shortcut, I can say 2 multiplied by the length plus 2 multiplied by the width, since they are the same number. So 2 times 7 and then 2 multiplied by 11 would give me 14 plus 22, which is 36 feet. Option number 2 is you see the 4 sides and you just add those together. That's totally fine too. 7 and 11 is 18. 18 and 7 is 25. 25 and 11 is 36. You should get the same answer no matter how you look at it. All right, now let's talk about area of a rectangle. So where perimeter goes around the outside, area is filling the space. So we're filling the inside of this. Area of a rectangle, we take the length and multiply it by the width. All right, we are taking 2 dimensions, length and width. Perimeter, single dimension. Our answer in units, single, just feet. Now that we're working with 2 dimensions and multiplying those, we will have units squared at the end. All right, so let's take our length multiplied by the width. So 36 meters multiplied by 12 meters. And you can put parentheses here if you would like to. If you don't like the little dot, put parentheses around those. Grab your calculator, or you can do it over on the side by hand, and we will take 36 times 12 and we get 432. You can either write out square meters or 432 meters squared. Either one of those will work, but that's the area of that rectangle to the right. All right, area of a parallelogram. Very similar to area of a rectangle. In fact, if you took this parallelogram and just kind of stood it up, this would be the height of that parallelogram. Again, parallelogram is base times height. Very similar to rectangle. Rectangle, you could use base times height on it as well. All right, so my base, you know, because we're all about the base. So my base is 7.8 meters. My height is 4.1 meters. I will multiply those together. 7.8 meters multiplied by 4.1 meters. So 7.8, if you want to pause and work that on your calculator, you can. 31.98 meters squared or square meters. It doesn't tell me to round to the nearest tenth, so I would just leave it like that. Another way you can write that is 31 and 98 hundredths, and you can write out the word square meters if you would like to. All right, notice the square is on the unit, never on the number. The square is on the unit of measure, never on the number. All right, last example. When we work word problems, we need to have a plan. All right, so we need to figure out what is the question asking, what am I given, right? What can I do with this? How am I going to go about solving this? So develop a plan and then put that plan into action and then check and make sure that it makes sense. All right, so let's start this and let's figure out what information they've given us and then where do we need to go from there. So Andre saved $825. He wants to replace the floor in his kitchen. The flooring he selects costs $2.49 per square foot. He knows the dimension of his kitchen. It's 15 feet wide and 24 feet long. So the question is, does he have enough money to buy the flooring, or is he going to have to save up and wait to buy the flooring? So let's see if he does. There's 15 feet by 24 feet. All right, now I'm just going to sketch a picture so I can see what I know, and then we'll see if there's any extra information and then kind of develop a plan. All right, so here's the kitchen floor that he would like to replace. All right, we know how much money he's saved up, and these tiles or this flooring is priced in square feet, not in length and width, but in an area that's covered. So we need to figure out how many square feet are in this kitchen floor. How big is it? How much space is it taking up? All right, so we're kind of starting to develop our plan. We need to know how many square feet or what area the kitchen floor takes up, and then we need to figure out how much it's going to cost. So I need area of the kitchen. Then I need to take that area and multiply it by the cost per square foot, and that will give me a total cost. Then I can compare that total cost to how much Andre has saved up, and I'll know, okay, can he afford it or can he not afford it? All right, so back to the area of this rectangle. How do I find the area of the rectangle? Area is length times width, so or width times length, 15 feet multiplied by 24 feet. So that's a pretty good sized kitchen. That's awesome. 15 times 24 is 360. 360 square feet or feet squared. We know the cost, $2.49 per square foot. So I can take this area, give me some space here. I can take this area, 360, and multiply it by $2.49. And the cost, the total cost will be $896.40 when I multiply those two together. Does he have enough money to replace his kitchen with this specific flooring that he wanted? He has $825. The total cost is pretty close to $900. He does not have enough money. He needs to continue to save or find a less expensive flooring to put down in his kitchen. All right, guys, we'll get to work when you get back to class tomorrow. Good job on this. Make sure you bring your notes to class. And this is Coach Lowe, and I'm out.